Okay, so this is the video for 3.2 lesson number 1, which is linear versus nonlinear functions. Hopefully you've printed out the note sheet that I put up. If not, you're taking notes in your notebook or wherever. Okay? All right, so want to know what linear means. So the definition of linear is a function is linear if it has a constant rate of change, okay? And you should also know rate of change is the same thing as slope, but we'll look at that more as we go on. Okay, so what do we mean by that? Well, if we take a look at example 1, rate of change is essentially just the pattern for the independent variable, the x, and the dependent variable, the y, okay? So your rate of change, x 5, 6, 7, 8, rate of change for x is plus 1, okay? Rate of change for y, well, from -2 to -7 is -5, okay? From -7 to -11, -4, and from -11 to -17 is -6, okay? So this does not have a constant rate of change, meaning this is constant, but this is not constant, okay? So is this a linear function? No, it's not. It's nonlinear, not linear or nonlinear. And its explanation for the choice is rate, oops, I'm gonna adjust my phone. There we go. Rate of change is not constant. Okay. All right, let's look at the second one. So in the x column, from -1 to 3, going up by 4, 3 to 7, up by 4, 7 to 11, up by 4. So that's constant, all right? What's the y column doing? Well, what's the change from -5 to -5? There is no change, so the change is 0. -5 to -5, 0. -5 to -5, 0. Is this linear? Yep, it is, because the rate of change is constant, okay? All right, example 3, we have 4 points, which looks a little different, but it's really not. Just make it look like the first 2 examples. So I'm gonna make another column with x, I'm gonna make a column for y. What x values do we have? 4, 6, 8, 10. Y values are 2, 6, 10, 9. Okay, let's look at the rate of change. 4 to 6 is up 2, 6 to 8 up 2, 8 to 10 up 2. Okay, so we're good for the x's. For the y's, up 4, but wait a second. Now we're down 1, okay? So is this a linear function? No, it's not. It doesn't have that constant rate of change, so it's not linear. Rate of change, not constant. Okay, let's go to the back of this page. Identifying linear functions from equations, okay? So instead of having a table or points that are on the graph, we're gonna have equations like that, okay? So in order to have a linear equation, linear equations look like y equals x plus 3, 2x plus 4y equals 8, okay? These are 2 examples of linear equations. One more, y equals 3x, all right? So these are some examples of linear equations. What are you not allowed to have? Well, you're not allowed to have exponents greater than 1. For example, y equals x squared. That is not a linear function, all right? You might have heard before of a quadratic function or something that graphs as a parabola, okay? That is not a linear function. And by the way, linear functions mean, besides the fact that they all have a constant rate of change, they're all going to graph as lines, look something like that, or go in the opposite way. Okay? All right. What else isn't allowed? Variables in the denominator of a fraction. Okay? So if we have x over y equals 1, well, we have a fraction, we have a variable in the bottom, the denominator of the fraction, automatically that's not linear. Okay? And last thing, no xy terms. So if we have xy equals 6, that's an example of something that's not linear. Okay? Let's take a look at a question. All right, so in this one, 7x plus 9y, 7x plus 9 plus 6y equals y minus 3. We're going to go through our checklist. Do we have any exponents greater than 1? No. All the exponents are 1s, right? When you just have x, y, it's understood that there's a 1 up there, okay? So is this linear? Yes, it is. Okay, negative 2y, wait, let me back up a second, sorry. I did not go through the whole list. Sorry about that. Okay, so exponents greater than 1. No, we're good there. They all have 1s. Variables in the denominator of a fraction. Well, we don't have any fractions here. Okay? XY terms. No, we don't have XY terms. All the X's and Y's are separate. So that's why it's linear. Sorry. Okay, letter B. Negative 2y equals 8. Exponents greater than 1. Nope, this has a 1 on top. Variables in the denominator of a fraction. Nope, no fractions. XY terms, we don't have any, so yes, it's linear. All right, C. Exponents greater than 1. Nope. Variables in the denominator of a fraction. Don't have any fractions. XY terms, well, we do have an XY term right there, so no, it's not linear. Okay. Last one. So exponents greater than 1. We're fine there. Variables in the denominator of a fraction. Be careful here. We do have fractions, but do we have variables in the denominator? No, we don't. We got 3 and 2. We got constants in the denominator. That's fine. XY terms, don't have any of those. So yes, it's linear. Okay. All right. The second one, linear or not linear. That one is linear. We're fine. We don't have any of the 3 things we mentioned above. For B, linear or not linear, it is not linear. We have a fraction that has a variable in the bottom, okay? That x in the bottom can't be there. Okay, C, they're trying to trick you. They're throwing in decimals, but again, it doesn't matter. Exponents greater than 1, nope. Variables in the denominator of a fraction, don't have any fractions. XY terms, don't have any of those, so we're good. All right, and D, you should see is linear, doesn't have any of those 3 things, okay? Go do the last one on your own and check back in a second for the answer. Okay, so here's what you should have had for the last one. First one's yes, second one is no, third one is no, and the fourth one is also no, okay? This doesn't have any of the 3 things we mentioned above. This has a variable in the denominator, not allowed to be there. This has an XY term, not allowed to be there. This has an exponent greater than 1, not allowed to be there, okay? And the last thing we want to do here, this assignment has some review material. I put this on there because this is especially important for 3.2. Okay, rewrite the equation in ax plus by equals c form. Use integers for a, b, and c. Remember, integers just means whole numbers, okay? So ax plus by equals c would be like 3x plus 4y equals 12, okay? Doesn't matter the numbers, I just made one up, but the key thing is the x and y have to be together on the same side, the constant alone. Okay, so here's how this works. And we've gone through this before, this should just be review. So we're gonna go y plus 6 equals 3x plus 15, just distribute out. Okay, we wanna get the x and y's together on the same side, so I'm gonna bring that over here by subtracting 3x, So we have, oops, there goes my pencil. All right, we have y minus 3x plus 6 equals 15, okay? So again, we want the x and y on the same side, and we want the constant alone, so I'm going to bring that 6 to the other side. So y minus 3x equals 9, okay? So we're almost there. What prevents this from being an ax plus by equals c form? Well, we have the c there, we have the constant, but the x and y are switched up. So we just want to turn it around. The x needs to come first, that's going to go negative 3x, the y second, plus y equals 9. And that's your answer, okay? Pause and go solve the bottom one. Okay, so y plus 5 equals negative 2x minus 6. I'm going to add the 2x. Y plus 2x plus 5 equals negative 6. Get rid of the 5. Okay, and of course we're going to swap this around because the x needs to come first. So your answer is 2x plus y equals negative 11. Okay, flip your paper. And the last thing we are doing is we're converting from ax plus by equals c form to y slope-intercept form so that we can identify the slope and the y-intercept. Remember, y equals mx plus b. M is the slope, and b is the y-intercept. Okay? So, review of how to do that. 6x plus 3y equals negative 3. We want to isolate y, so I'm going to get rid of the x. 3y equals negative 3 minus 6x. Divide everything by 3. Y equals negative 1 minus 2x. Again, this has to be an mx plus b form, so swap them around. Okay, now that we have it in slope-intercept form, slope is negative 2, the y-intercept is negative 1. Okay, pause and do the last question and check back. All right, so here's what you should have done. Get rid of the 12x. Divide through by 4. Okay. Y equals negative 1 minus 3x. Switch them around. Y equals negative 3x minus 1. Okay, so that means the slope is negative 3 and the y-intercept is negative 1. Okay? All right, that should do it.